A ship is sailing due north. At a certain point, the bearing of a lighthouse 12.5 kilometers away is north 38.8 degrees east. Later on, the captain notices that the bearing of the lighthouse has become south 44.2 degrees east. How far did the ship travel between the two observations of the lighthouse? Okay, so to do this problem, we need to understand how to interpret these bearings here, which for most of us, we'll never actually use these, but it's still interesting to understand what they mean. So, okay, what they're saying is you've got the ship is at a certain point, okay, and then it looks at the bearing of a lighthouse in the distance, and the lighthouse is at a bearing of north 38.8 degrees east. And so the way you interpret that is the first direction is do you reference the north or the south direction relative to the position you're speaking about? The first direction is just do you reference the north or south direction? So like we're taking this direction of the lighthouse from this position of the ship. So do we go to the north line or the south line? So we go to the north line, and now 38.8 degrees from the north line, but okay, but to the east or to the west? Well, it's to the east. So this angle here is 38.8 degrees. I probably drew that a little too big, but that's fine. Okay, but also at that point, the lighthouse is 12.5 kilometers away. Okay, later on, the captain notices that the bearing of the lighthouse has become south 44.2 degrees east. And so that this is later on, so we're going to be above the lighthouse because they give us, we start with the south line. Now the ship is sailing north, so it's going to be on this north line. It says the ship is sailing due north. So let's draw the ship up here. Okay, so at this point, the lighthouse has a bearing of south 44.2 degrees in the east direction. So this is 44.2 degrees. Okay, so the question is, how far did the ship travel between the two observations of the lighthouse? So they're looking for this length here, this length. But we can see that to solve for this length, we just need to solve this triangle. But can we solve the triangle? Well, what information do we have about the triangle? We've got two angles and we've got a side length. Well, we're good. Once you have two angles and a side length, then you don't have to think about, well, look, the side length isn't included between the two angles. It doesn't matter because we can automatically get the third angle since we've got two angles. And now we've got two angles and an included side length. We've got the angle side angle congruence postulate satisfied which means that this triangle isn't congruent to another triangle, but we use the congruence postulates to say that we've got two angles and a side length. That means that the triangle is fully constrained and we're able to solve it using the law of sines or the law of cosines. In this case, since we have two angles and a side length, we can use the law of sines in the non-ambiguous case. We can actually, the triangle is actually fully constrained. There's no ambiguity. We can get this exact side length and this side length if we need, but we don't need this. So, okay, let's do the law of sines. So, well, first let's get this angle. Let's get this angle here. So we've got 44.2 plus 38.8, and then take 180. So 97 degrees is this angle. Now we can use the law of sines. So we've got x over sine of 97 is equal to, now let's just pick, well, no, we can't just pick. We need to use this angle. So, because we only have this side length. So 12.5 over sine of 44.2 degrees. So x sine of 44.2 degrees is equal to 12.5 sine of 97 degrees. So x is equal to So x. Okay, so 12.5 times sine of 97 divided by sine of 44.2. 17.8 kilometers. And that's the answer.